Before we get into section 2.1 in your algebra book, we need to distinguish the difference between equalities and inequalities. Equalities is any expression with an equal sign. So for example, x equals 2, that is an equality. 3 equals 3. You would agree that this is a true statement, right? 3 does equal 3. And if we add, subtract, multiply, or divide both sides by the same number, you know through algebra that you will get the same thing. For example, if we multiply both of these sides by 2, you're going to get 6 equals 6. That's still a true statement. As long as you do the same thing to both sides, you will maintain the balance and keep the equality true. So equalities, addition, subtraction, multiplication, and division by the same number on both sides maintains the truth. Let's talk about inequalities. Inequalities is not an equality. You've got less than symbols. You've got greater than symbols. Less than or equal to, greater than or equal to. You are very familiar with these symbols. So we are going to explore how addition, subtraction, multiplication, and division affect the truth of inequality statements. So let's start with a true inequality. I think you would agree that 6 is greater than 4. Now if I add 1 to both sides, I'm not going to do that right now, but if I add 1 to both sides, you can think about it. You're going to get 7 is greater than 5. That is a true statement. If you subtract 1 from both sides, you'd get 5 is greater than 3. That's still a true statement. If you add a negative, that's the same as subtraction. So again, you'll have a true statement. But multiplication, when multiplication comes in, if you take 6 times 2, you get 12. 4 times 2, you get 8. 12 is still greater than 8. What I want to discuss is what happens when you multiply both sides by a negative, right? So we're going to take negative 2 times positive 6, and you're going to get 12. If I kept this inequality the same, you're going to get negative 12, because a negative times a positive is a negative. You'll get negative 12 is greater than negative 8. I want you to think about a number line here. The farther away you are from 0, the smaller the number. So here's negative 8, here's negative 12. Negative 8 is actually the larger number. Negative 12 is the smaller number. Therefore, negative 12 is actually less than negative 8. This is a false statement. In order to make this true, you are going to have to flip the inequality symbol, because negative 12 in actuality is less than negative 8. This is now a true statement. It maintains the validity of the original. And you'll see that the same is true for division by a negative. If you take 6 is greater than 4, that's our original statement, and we agree that that is true. If you now divide by a negative 2, you're going to get negative 3 compared to negative 2. If you keep the inequality symbol the same, you're going to get negative 3 is greater than negative 2, but negative 3 is farther away from 0. Therefore, this is a false statement. And in order to make this statement true, you are going to have to flip the inequality symbol. So negative 3, instead of greater than, it's less than negative 2, and now you have a true statement. So the point is, you should have already been familiar with this before. The point is that you must remember to flip the inequality symbol when multiplying or dividing by a negative number. And again, that's when we're working with inequalities, and it's so that we still have a true statement. Okay, let's get into section 2.1. We are ready to solve inequalities in one variable. You know what an inequality is. You know the symbols to look for that would represent an inequality. One variable means we only have one letter in the expression. So you could have x is less than 2. You could have 3x minus 5 is greater than or equal to 8. Right? And you can exchange x for different variables, different letters as well. You could have, or could you have 5a minus 2b is greater than negative 16/3. You could have this in math, but for the purpose of section 2.1, we're not going to worry about the multiple variables here. We're sticking with one variable. Okay, so we have to talk about how to solve these guys. Let's look at this example below. You've got 4/5 k minus 8 is greater than 8 minus 4/5 k. We want to figure out what values of k would make that inequality statement true. We want the left-hand side to be greater than the right-hand side. If you look up here at this inequality, x is less than 2, well, you know 1 is less than 2, 0 is less than 2, 1.5 is less than 2. There's actually an infinite number of solutions to that inequality, which is x is less than 2. So looking down here at our original, we have an idea that the solution set could possibly be an infinite number of solutions. So let's find this solution set. What we're going to do is solve algebraically as if we would an equality. So there's multiple ways you could do this. I'm seeing a denominator here. I'm seeing this 5 in the denominator, and I'm going to get rid of it. And I'm going to do that by multiplying both the right-hand side and the left-hand side by 5. It's a positive number. I can leave the inequality symbol the same. I do need to remember to distribute this 5 through both binomials on both sides, on either side. 4/5 times 5. These 5s cancel out, so I am left with 4k. And again, I need to distribute, so 5 times negative 8 is negative 40. I've got 4k minus 40. I'm going to keep the inequality the same. When I distribute this 5, I'm going to have 40 again. I'm going to have negative, my 5s cancel out, 4k. And notice that that is exactly why I multiplied by the denominator, because it should cancel out. I want it to cancel out so that I no longer have fractions, and the algebra is a little simpler. Okay, I'm going to collect my terms now. So I'm going, and preferably I want my variables on the right-hand side. In actuality, you don't have to have it on the right-hand side, but it's a little bit easier to keep them there, for me anyway. I've got 8k minus 40 is greater than 40. And now I'm working on isolating the k, so I'm going to add 40 to both sides. I'm going to extend this page, and I have 8k is greater than 80, and now I just need to get rid of the 8, and since it's being multiplied by k, I need to do the inverse operation, which is divide both sides, and division, always with an inequality symbol, should raise a flag. Make sure you flip it when you're multiplying by a negative. Here I'm not, so I've got k is greater than 10. So the directions say express in set notation and as a graph on the number line. I believe that any number greater than 10 should satisfy the original. So what I'm going to do here is I'm going to check first, right? Here is 0, here is 10, and I think any number greater than 10, I'm not going to fill the circle in because I know that I don't want to include 10 as a solution. Anything greater than that should make the original inequality true. So let's see, my denominator in the original problem is 5, so I'm going to pick a number greater than 10, but which is divisible by 5, just to make my work a little easier. So here's my check. 4/5 times, and I'm going to try, let's do 15. 4/5 times 15, and I'm going to put 15 over 1, minus 8. Is that greater than 8 minus 4/5 times 15 over 1? I see that 5 goes into 15 3 times. I see over on the right-hand side, again, 5 goes into 15 3 times. So now I can say 4 times 3 is 12. I've got 12 minus 8. Is that greater than 8 minus 4 times 3 is 12? I'm almost done here. 12 minus 8 is 4. 8 minus 12 is negative 4. And that is indeed, 4 is indeed greater than negative 4. So I have a little bit of confidence. It's not a formal proof, but I have a little confidence, actually a lot of confidence, that this is my correct solution set. Now, if you notice up here, it says to express your answer in set notation. We did it as a graph. We put it on the number line below. In set notation, we're just getting fancy here. You're in Algebra 2. You're going to speak mathematically savvy-like. So we just use curly brackets. We put the k in there. We use 2 dots. And then we say k is greater than 10. We end with the curly brackets. You might have to practice with the brackets. You'll get good at it with time. And this is actually read all k values. The colon means such that all k values, or all values of k, such that k is greater than 10. So you've got set notation, you've got it graphically, and you are done. Just to reiterate, hollow dot is for a less than symbol or a greater than symbol. It means that the number is not included in the solution set. Whereas a solid dot, less than or equal to, greater than or equal to, that actually means that the number would keep a true statement. All right, we're going to make very quick notes here. Very quick notes. You've got 3 steps here. I'm going to add a new page, and I want you to find space in your notes to write the steps to solving inequalities. Number 1, you're going to solve algebraically as if it were an equality. You guys know how to do that. But we showed that there's a difference between equalities and inequalities in order to maintain the truth statement. So what you need to do is remember to flip the symbol when multiplying or dividing by a negative number. You guys are going to get used to my notation. Number 3, you're going to test a point in the solution set. And you're going to hope that that gives you a positive, a true statement. And if it gives you a false statement, you should definitely recheck your work. Okay, so that is it. You've got 5 problems to try on your own. Numbers 1 through 5 for homework. Here's the first 4. You've got a 5th one. Don't cross number 6 out because we're going to go over it the next day on Tuesday. But give numbers 1 through 5 a shot, and we'll go over your questions when I see you next. Have a good weekend.